Welcome to the University of Michigan School of Information webinar on the Master of Applied Data Science degree. We're so happy to have all of you here today with us as we broadcast live from our homes surrounding the Ann Arbor, Michigan area. This is the first time that we've tried a webinar in this format, and we think it's going to be really successful. But please do bear with us in an instance where we have a technical challenge, as I'm sure most of, if not all of you, are practicing social distance. So are we here in Ann Arbor. And so I have two esteemed colleagues joining me today who are going to answer all of your questions about the MADS degree from their homes. I'll go ahead and let our faculty, Dr. Christopher Brooks and Dr. Yan Chen, introduce themselves. Chris, would you like to start?
Yeah, great. Thanks, Amy. I'm Chris Brooks. I'm faculty here at the School of Information. Some of you might know me from some of the MOOCs that you may have taken on applied data science, and I teach in the program and I do research on learning analytics. Yeah.
Hi, I'm Chen. I'm a professor at the School of Information. By the way, my name is not experiment design and analysis, as you might have inferred. That's the name of the course, the math course that I teach. And because I use that account, my laptop sometimes automatically default me to that account. So I am a behavioral and experimental economist, and I study economics of the internet, statistical principles of experimental design, and behavioral market design. If you've heard of that name, nudges and um, allocation algorithms, and so on. So I do both theoretical and experimental research.
Great, thank you so much. So, as those of you who have been with us before know, we will take the next hour or so answering your questions over YouTube. I welcome you to type in any and all questions that you have about the maths degree. I'm fairly confident that between the three of us, we'll be able to answer most of your questions. And if we can't answer your question today, we always welcome you to email umsi.mads, M-A-D-S, at umich.edu with any questions that we're unable to get to today. So, just to get started, I'd like to invite Yan and then Chris to talk a little bit about their experiences teaching in the MADS program. We're really fortunate that both of the faculty that are joining us today have produced and taught our MADS curriculum to current MADS students. And I'd love to get some of their insights about what it's been like to be a MADS faculty. Yan, can you tell us a little bit about your experience?
Yes, so I taught the SIAD 631, which is experiment design and analysis. You won't forget that because it's on my name tag. Uh, so, uh, so I developed this math course from the residential course that I teach. So I teach experiment design and analysis at the undergraduate level and at the PhD level. So what I do in the math course is to condense and take the most important and the best part of those courses and customize it to into a 1 month module. And so for every week there will be online lectures, the recorded lectures. You will do a homework assignment in the form of, reading, data analysis. You get a data set every week as a homework assignment that asks you to practice some of the statistical techniques we just learned, such as instrumental variable regressions, difference in differences analysis. And you will also be playing games on MobLab. And these games are designed to demonstrate the principles of the core concept that we learned in the class. During office hours, I would pull the data that was just collected from your class and look through these patterns, behavior patterns together. We do not have a final exam for my module because all of these core concepts are incorporated into these weekly exercises and quizzes. So it is a condensed version of my residential classes, but it is highly interactive in the sense that um, you will not only get to learn the concepts by listening to the instructor, but also by experiencing the concepts, such as free rider problems. Um, you will actually, in a mob lab game, you would actually be in a public project and you have to decide whether to free ride or not. And so in a chemistry experiment, it's very difficult for you to imagine what's it like to be a molecule. But for an experiment design and analysis class in the maths program, you would um, experience what's it like to be a subject, a participant in an experiment, and an experimenter. So you will get to experience this from both perspectives.
That's great, Yan. What I really appreciate about so much of what you just shared with us was not only the breadth and depth of an overview to a course like experiment design and analysis, but also your astute point that in the maths program, we're taking our residential courses and re-engaging them in a way that fits into the maths structure, but we're not sacrificing the pedagogy or the rigor of our courses. So I really appreciate you using examples such as the use of a tool like MobLab, which I know you also use in your residential course when
Yes.
teaching a maths course.
Yeah.
Chris, can you tell us a little bit about your experience teaching in the maths program?
Yeah, it was amazing. So I taught in the maths program one of the first courses that we launched, the data manipulation course last September, and I taught it again in January. So I would say almost 200 students now have gone through that course. It was absolutely amazing. One of the benefits of teaching in the maths program versus my residential program is instead of preparing my lectures every week, all of those are canned, all of those are in videos. And I get to spend my week actually engaging with the students through the office hours, through our Slack channel, doing some one-off examples in Jupyter notebooks, for instance. And Jupyter is like a technology that we use underneath in the MADS as kind of a foundation for the stack. So I really found that class wonderful. We use autograders throughout, so students in that class are able to do many different tests and get many different evaluations of their work. The other class I teach is a visual exploration of data. It's a visualization class essentially. And in that one, there's no autograders. It's all graded by our graduate students here at the university. We also have plenty of, well, we use Zoom actually for our office hours. And so we have plenty of contact with people. And in all of my classes, I try and use real data and real data sets and try and source some of those data sets from the MAD students themselves. Since those courses have ended, I've actually engaged with several of the students who are interested in some very specific domains, sports analytics being one. Several of those students who took the first couple of courses with me ended up doing some sports projects with me, did some sports projects on their own, and went to the MIT Sloan Sports Analytics Conference, for instance, this year, based off of that. So it's been a cool way to build cohorts and collaborations. And a lot of people maybe wonder, like, what's it like to do an online program? Am I going to know anybody? And it's amazing to see the connections that build between people and the sorts of projects that come up.
I have to agree, Chris. Even though we're an online program, we use a number of opportunities, such tools such as Slack, for example, or research opportunities with faculty, or our weekly office hours, like both you and Yan talked about, to engage our community of math students. And like you, I've been surprised, but pleasantly, at how many students we've gotten to know really well over the last year who've been engaging our program. Yan, we have a question about the kind of math background that's expected in the maths program. So, as we talk about in our admissions process, we don't require, for example, a specific math background in order to apply. However, at the same time, folks are interested in knowing, for example, what the statistics or the math, including things like linear algebra or multivariate calculus, might look like in maths. Can you talk a little bit more about how you use statistics in math in your course?
Yeah. So in my course, it's primarily statistics. So we assume the equivalence of stats 250 at the U of M, which is the first intro undergraduate stats class. And, that class started, you normally start with, what's a random variable? And it goes through, hypothesis testing, classical statistics, all the way to um, linear regressions. And that's where it stops, OLS. And we basically pick up from there. We assume that you know what type 1, type 2 errors are, but we actually would review it first before we use these concepts. So for instance, when we do power analysis, when you run an experiment, how do you compute the sample size? You have to know, the type 1, type 2 error and statistical power, but we do a quick review first, and then we build on that. We would assume that how to run linear regressions, and then we pick up from there. We would introduce, for instance, how do you estimate average treatment effects, heterogeneous treatment effects. When you have a panel data structure, how do you do difference in differences regressions? How do you construct an instrument and do instrumental variable regressions to tease out selection from your data set? So for each concept that we introduce, we use a concrete experiment that has been published and use that data set to demonstrate these different principles and ideas. So we would assume, if let's say that you've taken AP statistics, then you have all the basic concepts, and everything that we built on top of that, we would introduce them as if no one has heard of it before. But we'll just do a very quick review of the stats concept in, let's say, AP statistics with stats 50. You would use, I do not use linear algebra in my class, but I understand some of the other classes would. I use a little bit of differential calculus. So for instance, when we analyze auctions, we first derive the equilibrium bids. If everybody's rational and they're Bayesians, what do we expect them to bid? And to do that, you have to set up the objective function, take first order conditions, and solve for the equilibrium. So differential calculus is helpful in understanding these different concepts that we actually use as a component in our regression models. Chris, do you want to talk a little bit about where linear algebra is used, for instance?
Yeah, there's a couple of places where linear algebra is used in the course. So it's important to note that the maths degree also does have a math methods course that you would get introduced to very early on. I think it's the second course or third course in the sequence. And it reaffirms a lot of the concepts that we're expecting people to know. So a lot of machine learning uses matrices to represent data and transformations on data. And so that's where some of the linear algebra comes in. Also, some of the calculus comes in when looking at algorithms that use things like gradient descent. And I believe those are also introduced in the math methods courses.
Thank you. That was a really thorough overview to both how we employ statistics and math in our curriculum. So as Chris mentioned, we don't have a prerequisite math requirement. We do have a statistics assessment that all of our applicants must pass. So we and you feel comfortable with the basic statistics knowledge that you would need to be successful in the degree. And then as Chris aptly mentioned, we have a math methods course that is early in our curriculum that enables folks to get up to speed on concepts in linear algebra and calculus, for example, in addition to Bayesian statistics, that are all concepts and skills that we use in future maths courses. Chris, for those folks that are hardware engineers and have a little bit of scripting background, so not as much as a software engineer, for example, but at least some exposure to, how easy or hard would the program be for someone like that?
Yeah, I mean, that's a good question. So actually, one of the we have a few electrical and mechanical engineers, for instance, that are in the program, and some of them are some of our top students. Certainly, an engineering background demonstrates, for instance, like a degree in engineering demonstrates kind of an ability to engage with this kind of material, and so I would feel pretty confident in that. The challenge that one of the challenges that we really look at with all of the applicants is a programming background. And so, are you able to program? Now, that doesn't mean you have to be a computer scientist or a software engineer. It just means that you have to be able to program or be able to pick up enough programming in order to engage with the courses. We do have a programming requirement, and I think Amy, you can talk more about that. But largely throughout the MAD stack of courses, we use Python as the programming language. And there's lots of great resources to pick up uh, and improve your programming, including several MOOCs that we teach at the University of Michigan. Myself, Paul Resnick, and Steve Oney, for instance, teach one. Chuck Severance teaches another one that's quite popular. And so I would say that this was really a question about hardware engineers, but what I've observed is the early need for mechanical and electrical engineers is to pick up Python programming, but at a conceptual level, they're able to engage with the material very well.
Excellent. So to Chris's good point, we do also require a Python assessment, and we require it in one of two ways. Either you can take a Python test that enables us to understand that you and us have that we can assess you and you can assess yourself on foundational Python skill, or you can take the Python 3 certificate in Coursera. To Chris's point, that's taught by UMSI faculty, and then you can supply that certificate to us, and that you can use as an alternative form of competence to the assessment. I did want to mention that Dr. Chuck Severance's Python for Everybody is a great introductory course to Python. It is not the Python that we assess in order to get entrance into the maths degree. So we would require Python at the Python 3 level, which is above the Python for Everybody level. So if you're brand new to Python, I do suggest starting with Python for Everybody and then moving into Python 3. You can either complete the Python 3 certificate, or if you already know Python, you can take the Python assessment. So Yan, can you tell us a little bit about things that you consider in designing experiments? Oh no, okay. Well, we will wait for Yan to come back. It does happen as we all, okay. We're gonna take a quick break. We'll be back in a minute.
Yeah.
Okay. Thank you for bearing with us. As we indicated, we anticipated that there might be some technical challenges as we spend this hour together, but please stay with us. Anytime we have a technical glitch, we're working as fast as possible to make sure it gets resolved. So Yan, I was wondering if you could talk to us a little bit about how you or what you consider in designing experiments.
Can you be more specific?
Yeah, that's a good point. So this question from one of our viewers was simply, what are the things you consider in designing experiments and studies? So perhaps you could talk to us a little bit about
Okay.
the core kind of curricular components of an experiment design and analysis course.
Yeah. Okay. Um, let me first say that experiments are used all over the place in the tech industry and nonprofits, by the government. They're not always called experiments. In the tech industry, they sometimes call it A/B testing. Um, how extensive is it? Hal Varian, who's the chief economist at Google, said informally, but he allowed me to quote him, that there are at least 10,000 experiments conducted in Google. Facebook does the same thing. Um, as are pretty much every other place that I know of. Microsoft, the most important business of the day, again, this is quoting Susan Athey, who was the chief economist at Microsoft, was the Monday meeting of all the different uh, different executives. And during that meeting, they present first the results of their A/B testing or experiments and decisions to change policies, to change interfaces are based on these experimental results. And so we would basically use lots of these online experiments to introduce these basic concepts. In fact, I have my syllabus right here. So the textbook that I'm using is called Running Randomized Experiments, a Practical Guide by Rachel Glenister. So this is from the MIT JPAL lab. So you probably have heard the Nobel Prize in Economics was awarded to Esther Duflo, who was the director of that lab, and Abhijit Banerjee was also part of that lab. And we also recommend another one, which is called Field Experiments by Alan Gerber and Don Green. This is a little bit dense in terms of the technicality. So we start by introducing the idea of experiments of exogenous variations, and we then go through individual choice experiments and the idea. So what we use is the Uber tipping experiment, which actually amazingly is written up and circulated as a working paper. So remember, in the old days when Uber and Lyft first started, Lyft had tipping, but you can't actually tip in Uber. In the app, you can sort of hand cash to your driver at the end of the trip. So in their 180 days of change, they decided that, our customers, our drivers actually demanded tipping. So let's add that feature, but let's not just add it to everyone. Let's look at whether tipping changes, the attitude of the driver, whether it changes the demand from the consumers. And so they did it as an experiment. They randomized all the cities in Canada and the United States into the treatment arm and the control arm. They used a technique called clustered random assignment. And within clustering, they also use block random assignment. And so we go through basically an anatomy of this big scale experiment and see, why do you do clustering? And when you have to do clustering, what are the disadvantages? And what's blocking? Why does blocking improve your power? And so we go through this analysis. And so why would Uber do that? Why don't they just change everybody's interface all at once? So that's one example. So the techniques of randomization: blocking, clustering, simple random assignment, complete random assignment. So you will learn all these terms, and to find out what happened to the Uber experiment, you have to register and take the class. Then we look at statistical power. For instance, you decide to run an experiment. How many people do you need? How many schools do you need? How many firms, how many subsidiaries do you need to run this experiment? So we look at the statistical principles behind power calculation, and we give you numerical examples. We'll give you a data set and say, if you're given this data set and you're asked to design this experiment, how many subjects do you need in the control condition? How many in the treatment condition? So for instance, Google derives about 80% of its revenue from the position ads. These are sponsored ads, these little sections, sometimes at the top of your screen, sometimes at the right-hand side of your screen. How many do they put there? So, is 3 an optimal number? What about 4? If you add more, does it detracts from the expected revenue of the top 3? So this would require, something about auction theory, but auction theory is actually not developed to give you a very precise prediction of what about having four positions. And for that, you need a large randomized experiment um, to estimate the effect. So when people land on the page, some will see 3 ads and some will see 4 ads. And because they're randomized, they should have statistically equivalent samples from the control, the people who see 3, and the treatment, the people who see 4. And so how do you compute the sample size? We also look at various behavioral economic interventions, such as information nudges. For instance, when you inject social norms into an online community, how does that change people's behavior? And from that, how do you evaluate the effect of this type of intervention? We can look at, what did everybody do before versus after? Then we introduce the difference in differences regression technique to estimate the experimental treatment effect.
Yeah,
Maybe
it's,
it's yeah.
sorry, it's interesting.
Yeah.
Yeah, it's interesting that you should talk about online communities and studying online communities or using online communities as one way in which we understand experiment design and analysis, since our program is also an online community. And in fact, someone asked if we use our MOOCs or our MADS program to research online learning and behavior. So I know, for example, Chris, that you do study learning analytics and are already starting kind of the process of understanding learning in MOOC environments or in online degree environments. Do you want to build on the kinds of concepts that Jan's talking a little bit about around how we might use an experimental approach to studying online learning?
Yeah, in fact, so one of the MOOCs that I offered, we took a look at how we just changing the backgrounds inside of the MOOC, and we used an A/B test, a randomized controlled experiment, where half the people who saw the MOOC saw one background and half saw a different background, and the video was me shot in front of a green screen to try and understand if there was sense of inclusion differences between men and women. And so in the background, there were 2 data scientists working behind me, either 2 men or 2 women, depending on the condition. And so definitely, we shared that at the Coursera Partners Conference, for instance, about a year ago as well. So one of the things we're interested in doing is helping change education through our research and our practice. So while my background is learning analytics, that's kind of the research I do. I think as a school, we're also very interested in trying to move forward with many of the push these platforms forward and to bring that sense of social awareness to them using the very techniques that we're teaching in this program: experimental design and analysis, machine learning. For that one, for instance, I did a Bayesian analysis, and there's an uncertainty class, for instance, that's coming up with one of my colleagues, Matthew Kay, and so forth.
Great, thank you. Jan, and thank you for really giving us a thorough kind of understanding of how one might think about, kind of conceptualize and then act on experiment design and analysis. Now, Jan, I know that given your background in statistics, for example, you can talk about other ways in which the program incorporates statistics. So for example, we have a causal inference course coming up that I know is really heavy again in statistics and econometrics. Can you talk a little bit about the way in which we incorporate statistics, really kind of rigorous statistics, into courses like causal inference?
Yeah. So Professor Alan Cohn will be teaching the causal inference class in the fall. So causal inference is essentially a set of statistical techniques that enables you to tease out causality given a data set. So we often see a lot of correlation. So if you run large scale regression analysis, small scale, you often see, for instance, um, in the summer, we see ice cream sales go up, and the people drowning in city swimming pools also go up. So does ice cream cause drowning? We know from common sense that probably not. But how do you know that it's merely correlational versus causal? So this course, causal inference, is all about the statistical techniques that you use to differentiate between correlational versus causal effects in a data set. So for instance, we originally saw that, in this micro online finance community, microfinance community, Kiva, that people who belong to teams tend to be more active. So does teams make them more active? Or, we also see that before teams were created on the website, those people who eventually join teams were more active before. So there is a selection component. More active people, lenders are more likely to find that, oh, now there's a new mechanism called teams, and therefore I'm more likely to join, and they continue to be active. So the two competing hypotheses would be, more active people join teams, or teams merely gather these active people versus, you know, okay, more active people are more likely to join, but controlling for that, is there any additional effect that teams have in terms of making people more engaged in the community? And so you could use, for instance, combining recommender systems and instrumental variables. You can create, as an experimenter, you can create an instrumental variable, and which is totally exogenous to tease out the causality. So that's an example. And of course, it covers more techniques in largely from econometrics, but also some are from statistics.
Thank you. I appreciate that overview. I certainly think that it speaks to the ways in which we think kind of holistically about the core facets of data science, and understanding that statistics shows up in a number of different places, both in how we think about and actualize experiments, when we talk about where there's causality or not, and how we present visualizations, for example. So really using statistics in a number of different ways. I'm going to go ahead and answer just a couple of admissions related questions before I turn it back over to Chris. So we are hearing from a number of folks that are curious about, for example, how many students are in our cohort. So currently we have almost 200 active MAD students. We would anticipate adding another approximately 250 to 300 in the fall. So that's really kind of the number that we're looking for now. That's a rough number. It's not a hard and fast number. We're very pleased with the positive response that we've gotten so far from folks that have been admitted to and enrolled in the MATS degree, and we anticipate that it will continue to scale. Certainly the feedback that we've gotten from our students has been largely positive about the experience that they've had with us and with each other so far. In an instance where you do live in the Southeast Michigan area and you are a MAD student, you may avail yourself to on-campus resources. So MAD students are degree students at the University of Michigan. And for those students that live nearby, that may mean that you choose to engage in residential campus activities. This, of course, would be in a post-COVID-19 scenario where the campus is open. As Chris and Yan and I can tell you, it's currently not. So we don't go to campus, and nor do any of our students, but certainly that would be a possibility in the future. For those of you that are not living in Southeast Michigan, however, it does not mean or preclude you from still engaging in our campus community. So for example, you still have full access to the library. You still have all of the career resources and access to the career development office that our residential students have. We live stream events in the School of Information for our MAD students to join, as well as campus events that are put on by some of our partners. For example, we have a data science institute at the University of Michigan that we will often live stream or point our students to their events in an instance where they're being live streamed. We've had several students that have come to visit Ann Arbor and have participated in things like a football game, for instance. So there's lots of opportunities for students to engage in the campus community, be it in person or online. And certainly we're sensitive to ensuring that all MAD students have a full University of Michigan experience, regardless of where they live. For those folks that have applied, I can tell you that we are close to starting to release admissions decisions. So in the initial round, we indicated 4 to 6 weeks. We're approaching the 6 week mark, and my admissions team indicates to me that they're very close to finalizing the reviews for that first round and making admissions decisions. So, for lots of you, you might be thinking about how you're funding the maths degree. I will tell you that we do offer scholarships, and that's actually quite unique to an online program. How we do that and how much we offer, those are things that are really made in by choices that are made by our admissions team with support from our Office of Academic and Student Affairs. It varies from year to year, so there's no hard and fast rules on how we give out scholarships. The good news is that you don't have to submit an additional application to be scholarship eligible. So, in an instance where you're admitted into the maths degree, you are also automatically considered for scholarship. And then someone did inquire about how to demonstrate English language fluency in an instance where you're unable to access a TOEFL center right now. So if you email umsi.mads, M-A-D-S, at umich.edu, we are happy to provide alternate means through which you can test or we can verify your English language fluency. So we recognize this is an issue. We don't want this to be a barrier for anyone. We want you to submit your application. We're happy to work with you on alternative means of recognizing your English language fluency. And by emailing us, we can point you to some specific resources. And then finally, we got a question about the difference between completing the degree in a year versus two. So the good news about MADS, and particularly starting in the fall of 2020, is that we have a really flexible curriculum. So you can take as long as 3 years, for example, with just 1 credit a month to graduate. You can take 3 credits a month and do it in 12 months, for example. So there's lots of flexibility in how you traverse the MADS curriculum. You can take courses for 2 months and then take a month off and then come back into taking courses. And we've observed students that have engaged in this model in a number of different ways. Students that have started on 1 credit and then moved up to 2, students that have started at 2 and then gone down to 1. We see students that indicate that they want to move very quickly, and we have other students that want to move very slowly. So the good news is that we have a number of different ways for which you to traverse the curriculum, and it's really designed with that intention in mind. Chris, can you talk just a little bit more about that idea of kind of how we've designed the maths curriculum to be flexible and responsive to a diverse number of learners?
Yeah, so one of the things I was on the committee that originally designed the program, and one of the things that we really wanted was to give that sense of flexibility. And so the first thing we did is we switched to 1 credit unit, 1 month long classes. And this has a couple of interesting pieces to it. The classes are, I would say, rigorous. There's no padding. You have 4 weeks to get through a concept. So unlike in a residential class where we're sometimes trying to fill 13 weeks, we've got 10 weeks worth of content or 9 weeks, and we're adding extras. That's We're very focused in the maths classes, and this allows people to really get a lot of value out of them per credit unit that they're paying for and registering for. It also allows you to scale how much effort you want to be able to put in or you have available to you. So a lot of our students are employed, either self-employed or employed by somebody, and are taking different numbers of classes in different months based on their obligations for their employment. For instance, I talked to one student who had some things crop up with his business. He knew that he was going to have to be on site for a few months, and so did not enroll in as many courses those months because he was going to be working longer hours. So that's one example of how the flexibility of this 1 credit unit program works.
Great, thank you. So, Chris, you alluded to the fact that the maths degree is not less rigorous than the residential program, that although they take two really different formats, they still really are based on kind of the same premise in so much as how we teach data science, and that in some ways, maths has some benefits, like we would say the residential programs have, but some unique benefits as compared to our residential MSI, for example. Can you talk a little bit more about what some of those differences or similarities are.
Yeah, so I think a lot of the content is very similar or can be very similar. So our MSI program actually is made up of several different tracks, and data science is just one of those tracks. So we also have a human-computer interaction, social media, a library, etc. So we're just focused on the comparison with looking at the data science piece. The big differences are on campus. You're locked into 3 credit unit classes or sometimes 4 credit unit classes almost throughout. The classes are a little bit longer. It's a 2-year degree, but there's an internship in the middle of it. In the MADS program, there's no internship, and you can do it in as short as 12 months in these 1 credit unit classes. And part of that is because if you're doing it in 12 months, you're going all 12 months, whereas we don't offer most of the MSI classes in our residential masters in the summer because those students are sometimes going off to do internships. What I find from the students as they're choosing between these two programs is they're often doing it for that internship, whether they feel they need to be residential and in the United States to do that internship, versus they feel that they can find internship opportunities of their own, or they're enrolling in the program for job movement, either horizontal or vertical within their existing field. Many of the students, I would even say maybe most of the students are in the MADS program are employed, whereas almost none in the MSI program, our residential program, are employed, at least at that time. At the same time, there are still these opportunities to engage with us as faculty. So I've actually employed some of our MAD students to do research work for me. I have the video chats with students. I've actually given more advising hours to MAD students than I have to residential students this past year. The online format is flexible, but it doesn't have to be limiting.
Great, thank you. That was a really thorough response to how we navigate across our different programs and acknowledging that all three of us as University of Michigan School of Information employees value all of our programs. And as we indicated, there are definitely some unique benefits to the MATS degree, while also acknowledging that the MSI, of course, is still a great program too, depending on what your objectives are. So, Yan, relatedly to kind of what differentiates MADS versus some of our residential programs, we of course talk about what's synchronous, like where do MADS students show up live? What's asynchronous? When do they when are they kind of in Coursera watching lecture videos or doing readings or assignments? Can you talk a little bit about when you meet with MADS students live and what that's like versus when they're engaging in asynchronous learning? I think maybe I I'm looking over at Yan. I don't see her. So, Chris, why don't you go ahead and tackle this one for the moment until Yan comes back?
Can you repeat the question, please?
Yes, of course. I was just asking you to talk a little bit about how synchronous versus asynchronous learning works in MADS.
Right. So it changes depending on the course, but the majority of the learning starts with you logging into the Coursera shell and being able to watch videos. And these videos are roughly analogous to lectures. Now, through those videos, there might be various different forms of interaction. And there's Jupyter Notebooks. So we've got the programming environment built right in. The synchronous part comes in through weekly office hours. And in my courses, for instance, we have 3 hours of office hours every week. The instructor, I would give at least one of those, sometimes two of those, and then we would have graduate student instructors also give a few of those. One of the things I did last semester was a Twitch live stream every Sunday as well, where I would just work on some Python projects and I would be able to share those with students and people could just drop in, and it was kind of like a Hangouts code time where we could talk about things, whether they're directly related to the course content or not. Some of the courses also use video from the students as part of the assignments, for instance, small presentations or demonstrations back to the students as well. But the majority, I would say, of the format is asynchronous. And one of our goals with the program was to allow people to be able to complete any of the courses in an asynchronous mode if it required. And so we use Zoom for our office hours, and we record those office hours, and they're made available, and we give summaries of those office hours as well. And this is really useful for time zone issues or other obligations. Now, you may have mentioned, I think earlier, that we use Slack as well. We have a degree-wide Slack. All of our students are on Slack. And you can think of this like the building that we're in. These are the halls, the classrooms, and so forth. And you can hang out in that Slack and ask questions and keep abreast of announcements. We have a jobs channel in the Slack. We have a couple of student groups that have started. One was called Sports Analytics. The other was called the MADS Weekly Workout, where people were just trying new problems to keep their skills fresh. And we're looking to expand on those kinds of offerings for the students as well.
Great, thank you. Yeah, and welcome back.
Thank
So,
you.
you know what? We're just rolling with it. We're doing what we can do. Uh,
Yeah.
so, to Chris's point about jobs, can you just talk just generally about where you've seen some of our UMSI grads go on to? So, what kind of jobs do they get, for example, or what are those jobs like?
So our MSI program is a lot more diverse in terms of the areas covered than maths currently. So I am more familiar with the information economics for management track. So the MSI equivalent of maths is information analysis, I guess. Um, so for the and in some courses, some of my courses are cross-listed with information analysis and also HCI. So our graduates, some of them become consultants, and at Deloitte or the Boston Group, and there are people who have the analyst title, and so we also have a fair number who from the HCI track, they become um, UX designers, and we also sent people out to, for instance, Amazon. They become data scientists, and we have students going to Facebook, to Uber, and yeah, a fairly diverse number of companies. And um, also, I think to more traditional sectors like the Ford Motor Company. So those are our MSI graduates. I think if the statistics is current, actually about 20% of them go on to PhD programs. And yeah, of the IEM track, the information analysis, the information, okay, the the IEM information economics for management track, there are more analyst positions, people taking on analyst positions.
Right. Yeah, I think that that's a really great overview to where and what kind of roles our students end up in. So, for example, we would anticipate that MAD students, like our residential data science students, may take on data scientist positions in large companies. I know, for example, you mentioned Amazon, Facebook, Google, Uber, as well as in government agencies or NGOs or even nonprofits, for instance.
Yeah.
And certainly the reputation and strength of the School of Information is shown in our job outcomes in so much as where our students go. I know that in conversations that I've had with our career development office, that our information analytics students or otherwise our data science students, which MADs are some of the most in demand in a number of different large and small organizations, taking on data science positions, as Chris mentioned earlier, within a number of different subfields, including health, sports, consulting, finance, amongst others. So I certainly think that We are don't have graduates yet, but we're very excited to see where our graduates go, both those that are going to propel themselves within the organizations they're already in, and those that will pivot into data scientist positions from industries that they will be leaving. And we're seeing both as in so much as what our MAD students are telling us.
Mhm.
So, Yan, I did also want to just mention thank you for talking a little bit about PhD students. Although the MADS degree itself is not a PhD granting program, we could anticipate, for example, that one or more MADS students do apply to PhD programs. Certainly, we're well versed as a faculty, for example, in how to navigate that process. And so we could see a future state where we are at least supporting students who want to go on to get a PhD.
Yeah.
So, Chris, could you talk just a little bit about our machine learning courses?
Yeah, so we've got a breadth of machine learning courses. This has become, for computational data scientists, has become sort of the bread and butter now of what's done. So Kevin Collins Thompson is teaching two of them coming up. One and people might know him if they've taken some of our applied data science MOOCs. So he's got a supervised machine learning course as well as an unsupervised machine learning course. And the difference between these is really the task. Do you know what you're classifying already? So you want to make a prediction task, or are you trying to cluster things together and try and see what's similar about things? We also have a deep learning course that's being put on, and I think we're using Keras as the Python library in that. We have a natural language processing course and a networks course. The networks course is being taught by Daniel Romero, who is also one of the colleagues in the who helped teach some of the MOOCs. I would say if you look at our program, the first third of the program is fundamentals and getting ready. So there's data manipulation, data cleaning, visualization, and so forth. And then after the first third, we have a milestone, and that milestone is project based. It's 2 months, so it's 2 credit units long, and it's an opportunity to put into action a little bit more what you're doing in a self-directed project. Then I would say the second third of the degree is really machine learning and more advanced topics. And after that, there's another 2 credit unit project class where you actually can build a portfolio piece of what you're doing. And then the last third of the degree is the applications. Now, you'll still learn some methods there, but you'll also take three, I believe, different applications courses. We have a number of them being developed right now, for instance, social media analytics. But we actually have a variety that people are excited about maybe offering that we haven't done yet. And we've one that's come up naturally from interaction with students is about sports. There's learning analytics, which I'm quite keen on seeing developed, and so forth. So in at the end of that third, there's a capstone project that's a 3 credit unit portfolio piece that you would build as well. So I think that that's an important part of the program. It's not you don't come out becoming a machine learning engineer. You come out having a strong breadth across, as well as projects that demonstrate your depth and ability, and you get some say and some direction in what those projects look like as far as building a portfolio of your own.
So, Chris, it sounds like you're saying that the sources for the projects, although we may aid you in finding data sources, for example, that you do get a lot of direction in how you choose to apply your data science skills in those projects, because ultimately they become the portfolio that you might use with employers. Is
Yeah, and
that
I think right now the milestone class just started. Actually, the first milestone class just started, and students are able to propose their own projects. They get feedback on those. They can do them in teams as well, which has been interesting. Of course, these could all change as we learn what works and what doesn't work in the milestone classes. But we do have this interest in helping all of our students throughout our program not just learn what we're saying, but be able to put it into action. And so the school has this slogan that information changes everything, and we want to help people change everything. And so if you're passionate about financial markets, if you're passionate about healthcare, if you're passionate about the governance topic X or homelessness or these things, then we want to help you be able to to put your energies and your learning in that. And so this is really an applied data science degree. We're not just going to throw techniques at you. You will get techniques thrown at you, but we're not just throwing techniques at you. We're also giving you an outlet to explore the application of those techniques in a meaningful way.
And Yan, isn't it true that one of the courses that you're actually thinking about is a data science for the public good, or a course that kind of focuses on how we might apply data science to public problems, for example?
Yes, so I'm going to prepare a course called Data Science for Social Good. And so this talks about, it's going to be using the data science tools to do interventions such as reduce, water preservation, reducing traffic accidents, you know, getting people to make more, zero interest loans to small businesses in developing countries. So it's geared towards problem solving. So we have a number of social issues, and how do you motivate people? How do you use the tools that we learned in the core in experiment design, recommender systems? How do you use them towards solving social problems? And I am also, as we speak, trying to get the data from the Harvard group on how we feel, the new app that they launched to get people to enter their health information for COVID-19. So I'm excited to be assembling several large data sets so that the students could use to see how one might design solutions to social problems.
That's very exciting. And what I appreciate is that you are helping gather those big data sets, because we do have a number of courses that focus on big data and how to analyze it, and yet also having a lot of potential social impact in how we think about and use data for social good. So, as we spend our last couple of minutes together, I just wanted to remind folks that in an instance where we don't get to answering your question, you are always welcome to email us at umsi.mads, M-A-D-S, at umich.edu, and we are welcome to answer your questions there. I do see a couple of specific questions, for example, that we may not touch on in our last minute or two together, but we're happy to answer those questions individually over email. So, Chris and Yan, could you spend just 30 seconds telling us why you would tell somebody to come to the School of Information MADS degree program? So, what's your takeaway on why MADS? Chris, I'll let you start.
Yeah, so I'm a computer scientist by background. I did not go to a school of information. And so it's been amazing. I've now been at the School of Information here for 7 years. And it's an amazing diversity of student body and of faculty. So I get to work with colleagues who are not just computer scientists and not just interested in the algorithms, and really focus on application. And to me, that's one of the promises schools of information have for changing the world for better, is the application of techniques. In the MADS program, the application of those techniques are data science techniques, and my background is computational data science techniques. So building applications that are going to use data to change things. I think that that's a powerful value proposition. What you get out of this program will be something that you can use regardless of the industry that you're in part because you can tailor what it is you want to be doing. A lot of our students are employed, but you don't have to be employed. You can do this full time. We actually have one or more students who are on the campus residence, in the graduate student residence, even though there's no need necessarily to do that. So it's a super flexible program, and I think that that's the biggest opportunity here with the MADS degree.
Thank you. Yan, what would you say to a person that's interested in joining MADS?
Well, apply, and I think it will be a great experience for you. Um, so the faculty are all at the cutting edge of research on data science. So I think you will get exposed to the newest techniques and methods. Um, and the most pressing, problems in our societies face. We get to know how we approach them.
I really appreciate both of your sentiments that we're creating an agile curriculum for folks to come into from in a number of different stages and places in their careers and lives, and that we enable them to use things that they care deeply about to tackle thorny data science problems and issues for the betterment of society and to change the world, as Chris indicated earlier. So thank you so much for joining all of us today. As I indicated before, please do email us at umsi.maths@umich.edu if you have any additional questions. And otherwise, we greatly look forward to reviewing your applications. As always, go blue.